Have you ever stared into the night sky and wondered how it all ends? Not just life on Earth or the stars above, but everything, the universe itself. Tonight, we're going to explore, step by gentle step, what science says about the end of time itself. This is a journey from the simplest concepts to the most complex theories, across 50 levels of cosmic understanding. And as we go deeper, let your mind drift. Let curiosity guide you, and sleep, if it comes, take you gently. Level 1. The stars. Go out. Let's begin with a simple image. Stars twinkling in the vast expanse of the night sky. Billions upon billions of luminous suns, each burning steadily with the power of nuclear fusion. They are the cosmic furnaces that have lit up the universe for billions of years, shaping galaxies and seeding the elements necessary for life. But this brilliance won't last forever. One day, every star, no matter how massive or small, will exhaust its fuel. Our own sun will expand into a red giant, consume its inner planets, and eventually collapse into a white dwarf. Other stars will follow similar paths, some ending as dense neutron stars or black holes. Over eons, without fresh hydrogen to sustain them, no new stars will be born. The existing ones will fade, flicker, and die. The night sky, once ablaze with light and motion, will grow darker and colder. In time, all that remains will be the remnants of what once was, a silent, empty sky without stars. Level 2. What happens to our sun? Our own star, the sun, is not eternal. In approximately 5 billion years, it will exhaust the hydrogen fuel at its core, the energy source that has kept it stable and shining for over 4.5 billion years. As the hydrogen runs out, the balance between gravity and pressure will break. The sun's core will contract under gravity, while its outer layers expand outward, transforming it into a red giant. In this bloated state, it will grow so large that it will engulf Mercury and Venus, and possibly even Earth, incinerating our planet in the process. The sun will be unrecognizable, a swollen, fiery sphere stretching across our sky. Eventually, it will shed its outer layers, creating a glowing shell of gas known as a planetary nebula. What remains at the center is a white dwarf, a hot, dense core, roughly the size of Earth but with half the sun's mass. It will glow faintly, gradually cooling and fading over trillions of years into a cold, dark, stellar corpse. Level 3. White dwarfs. Cool down. Once a star like our sun ends its life, it leaves behind a white dwarf, a small, incredibly dense core glowing with residual heat. These stellar remnants no longer produce energy through fusion. Instead, they slowly radiate away the heat left over from their former brilliance. Over the course of trillions of years, far longer than the current age of the universe, these white dwarfs continue to cool. Their light dims gradually, fading from white to red, and eventually disappearing entirely from view. With no energy left to emit, they become cold, dark, and invisible, black dwarfs. These hypothetical objects represent the final, quiet end of stellar evolution. But here's the fascinating part. Because the universe is only about 13.8 billion years old, not enough time has passed for any white dwarf to fully cool into a black dwarf. In other words, black dwarfs don't exist yet. They are part of a future far beyond our reach, in a universe that will be dark, still, and silent. Level 4. Galaxies Age 2. Galaxies, vast collections of stars, gas, dust, and dark matter, are not timeless. They evolve and age just like the stars within them. In their youth, galaxies are vibrant, dynamic places where new stars are born in brilliant bursts of light, lighting up the cosmos in dazzling displays. But over billions of years, this activity slows. The raw materials needed for star formation, cold gas and dust, gradually get used up or blown away by supernovae and black hole activity. Fewer and fewer stars are born. Existing stars burn out, becoming white dwarfs, neutron stars, or black holes. Spiral galaxies like the Milky Way may merge with others, morphing into more passive elliptical shapes. Eventually, the galaxy grows dimmer and quieter, filled mostly with ancient fading stars. The once vibrant cosmic fireworks give way to a still, dark calm. Galaxies, once bustling with energy and creation, become quiet cities of stellar ghosts in a fading universe. Level 5. No more new stars are born from clouds of cold hydrogen gas collapsing under gravity. This gas is the fuel of cosmic creation. But over time, galaxies consume their hydrogen. It forms stars, and those stars eventually die, sometimes returning a bit of gas to space, but never enough to sustain star formation forever. Slowly, the galactic reservoirs run dry. No more bright nurseries of newborn stars. No more brilliant blue giants lighting up nebulae. As the supply of hydrogen dwindles, the universe enters a quiet phase. New stars stop forming entirely. The galaxies become cemeteries of aging suns, filled only with the dimming glow of ancient stars nearing the ends of their lives. No new light is born to replace them. The skies, once filled with stellar birth and death, will fade. A stillness will settle across the cosmos as the era of star formation comes to a final, silent close. The universe grows darker, not in a single moment, but forever. Level 6. The universe expands. The universe has been expanding ever since the Big Bang, but it's not just objects moving through space. Space itself is stretching, growing larger over time. As this expansion continues, galaxies drift farther and farther apart. The vast cosmic web that once seemed tightly knit begins to thin. Distant galaxies recede so quickly that their light becomes red-shifted beyond visibility, disappearing from view entirely. The night sky, once full of countless stars and galaxies, will gradually grow emptier and darker. Eventually, only the closest galaxies, perhaps only our own local group, will remain visible. Everything else will fade beyond the cosmic horizon, unreachable and unseen. The expansion of space means the universe isn't just getting bigger, it's becoming lonelier. Over trillions of years, this relentless stretching will isolate entire regions of the cosmos, locking them into silent solitude, surrounded by darkness. Level 7. Redshift. As the universe expands, it stretches not just space, but the light traveling through it. This stretching increases the wavelength of the light, shifting it toward the red end of the spectrum, a phenomenon known as redshift. The farther away a galaxy is, the faster it appears to move from us, and the more its light is redshifted. Over immense distances and timescales, this effect becomes extreme. Light that once shone brightly in visible wavelengths becomes stretched into infrared, then microwave, and eventually into radio waves, until it fades completely from detectability. Even the most powerful telescopes will no longer be able to see the light from distant galaxies. The cosmos, once filled with a vibrant tapestry of light, will seem increasingly empty. Redshift doesn't just hide the past, it erases it from view. In the far future, it will be as though the rest of the universe never existed at all. Level 8. Dark energy accelerates it. For a long time, scientists thought the expansion of the universe might slow down over time due to gravity. But observations of distant supernovae revealed something surprising. The expansion isn't slowing, it's speeding up. This accelerating expansion is driven by a mysterious force we call dark energy. Unlike gravity, which pulls matter together, dark energy pushes space apart. It acts as a kind of anti-gravity, causing galaxies to move away from each other faster and faster as time goes on. The exact nature of dark energy is still unknown, but its effects are undeniable. Over billions and trillions of years, this acceleration means galaxies will vanish from view at an increasing rate, slipping beyond our cosmic horizon forever. Eventually, only the remnants of our own galactic neighborhood will remain. The universe will not only grow darker, it will also grow more isolated as dark energy relentlessly stretches space itself. Level 9. Isolation begins. As dark energy drives the accelerated expansion of the universe, distant galaxies recede faster and faster. Eventually, they will cross a point of no return, the cosmic event horizon, beyond which their light will never reach us, no matter how long we wait. Over time, more and more galaxies will vanish from view, not because they've ceased to exist, but because space itself is expanding so rapidly that their light becomes forever unreachable. What remains is our local group, a small cluster of galaxies including the Milky Way, Andromeda, and a few dozen dwarfs. Bound together by gravity, these galaxies will resist the pull of expansion and remain close, even as the rest of the cosmos fades away. In the far future, our local group will become a lonely island adrift in an unimaginably vast and empty universe. All evidence of the broader cosmos will be lost to time and distance. The era of cosmic isolation will have begun. Level 10. Cosmic Horizons. The universe is vast, but we can only observe a limited portion of it. The observable universe, bounded by the distance light, has traveled since the Big Bang. This boundary is called the cosmic horizon. Anything beyond it lies forever out of reach, not because it doesn't exist, but because its light hasn't had enough time to get to us, or never will, due to the accelerating expansion of space. As dark energy continues to drive galaxies apart, more and more of them will cross this invisible threshold. Their light, stretched by redshift and delayed by distance, will never reach us. These galaxies aren't gone, but to us, they might as well be. Eventually, only the galaxies bound by local gravity, like our local group, will remain within our horizon. The rest of the universe will slip beyond our view, lost in the ever-growing vastness. Cosmic horizons aren't walls, but they are boundaries, and over time, they define the limits of what we can ever know. Level 11. The Milky Way-Andromeda Merger. Long before the universe fades into isolation, a dramatic event will reshape our night sky. In about 4 billion years, the Andromeda Galaxy, our closest large neighbor, will collide and merge with the Milky Way. Though galaxies are full of stars, the vast distances between them mean that actual star-on-star collisions will be rare. Instead, the gravitational chaos will trigger waves of star formation as gas clouds crash together and compress. For a brief cosmic moment, the sky will ignite with bursts of new stars, brilliant and short-lived. Over time, the two galaxies will settle into a single, larger elliptical galaxy, sometimes referred to as Milkomeda. The spiral structures we know today will be gone, replaced by a more uniform, rounded shape. To any observers alive then, the night sky will be completely transformed, filled with dazzling stars and strange structures, a temporary burst of beauty before the long quiet ahead. Level 12. A new galaxy forms. When the Milky Way and Andromeda collide, they won't just pass through each other, they'll merge into a single massive galaxy. This new galaxy, often nicknamed Milkomeda, will be a blend of both spirals, transformed by gravity into a more rounded elliptical shape. At first, the merger will be chaotic. Stars flung into new orbits, gas clouds crashing together, and bright waves of star formation lighting up the night sky. But the chaos won't last forever. Over a few billion years, the dust will settle, literally and figuratively. The raw material for star birth will be used up or dispersed. The intense star-forming activity will fade. What remains will be a quiet, mature galaxy, filled mostly with aging stars. No grand spiral arms, no fresh waves of light, just a vast, glowing population of suns slowly burning out. Milkomeda will stand as a beautiful monument to a cosmic past, quiet, massive, and surrounded by an increasingly empty universe. Level 13. Black holes grow. At the center of nearly every galaxy lies a supermassive black hole, millions or even billions of times the mass of our Sun. These titanic objects shape the galaxies around them, influencing star formation and galactic structure. When galaxies collide and merge, like the future union of the Milky Way and Andromeda, their central black holes spiral toward one another, eventually merging into an even larger black hole. During this process, they feast on nearby gas, dust, and stars, flaring brightly as active galactic nuclei or quasars. With fewer new stars forming and most matter settling, black holes become the last truly energetic engines in the universe. Over trillions of years, they will continue to consume what little remains: wandering stars, rogue planets, and interstellar debris. As everything else fades into silence, black holes endure, growing ever more massive. In the far future, they will be the dominant final architects of the cosmos. Level 14. Hawking radiation. In the 1970s, the renowned theoretical physicist Stephen Hawking made a groundbreaking prediction that challenged the long-held belief that nothing could ever escape a black hole. He proposed that black holes are not entirely black, but can actually emit a very faint form of thermal radiation, now known as Hawking radiation. This phenomenon arises due to quantum effects near the event horizon, where pairs of virtual particles constantly pop in and out of existence. Occasionally, one of these particles falls into the black hole while the other escapes, making it appear as though the black hole is radiating energy. As a result of this slow and steady emission, black holes lose tiny amounts of mass over time. Although this process is incredibly slow for large black holes, taking longer than the current age of the universe, it implies that black holes can eventually evaporate completely. Hawking's theory bridged quantum mechanics and general relativity, sparking profound discussions in modern physics. Level 15. Protons. May decay, protons, the positively charged particles found in the nucleus of every atom, have long been considered stable and eternal. However, some advanced theories in particle physics, particularly grand unified theories, GUTS, predict that protons may not last forever. According to these models, protons can decay into lighter subatomic particles, such as positrons and neutral pions, albeit over incredibly long timescales, far exceeding the current age of the universe. This hypothetical process has never been observed directly, but ongoing experiments in massive underground detectors are searching for signs of it. If proton decay is real, it would have staggering implications. Over unimaginable spans of time, all matter in the universe could eventually break down, leaving a cosmos filled only with radiation and subatomic particles. This idea touches on the ultimate fate of matter itself and hints that the universe may not just end with the stars going out, but with atoms themselves disintegrating. Level 16. The degenerate era begins. As the universe continues to age and evolve over trillions of years, a new cosmic chapter unfolds, the degenerate era. By this time, all main sequence stars have exhausted their nuclear fuel and faded from the cosmos. The brilliant light of stars that once filled the night sky is gone, leaving behind the remnants of stellar evolution: black dwarfs, neutron stars, and black holes. These are the degenerate objects, ultra-dense, compact leftovers that no longer produce energy through fusion. The universe becomes a dark, cold, and quiet place, with only the occasional flicker from matter falling into a black hole or the rare collision between stellar remnants. Black dwarfs, theoretical remnants of white dwarfs, will take trillions of years to fully form, glowing faintly from residual heat before cooling to near absolute zero. Neutron stars spin silently, and black holes lurk in the shadows. The cosmos enters an age of stillness and decay, a far cry from the vibrant, star-filled universe it once was. Level 17. Galactic Remnants. Drift. In the vast emptiness of the far future, the universe continues its inexorable expansion, stretching space itself to unimaginable scales. During this era, all that remains of once brilliant galaxies are stellar remnants, black dwarfs, neutron stars, and black holes, quietly drifting through the darkness. These objects are the long-lived leftovers of a universe that has grown cold and silent. With most sources of light and energy extinguished, these remnants become like cosmic ghosts, isolated and dim. As galaxies dissolve due to gravitational interactions and cosmic expansion, their constituent parts scatter, rarely encountering one another. The immense distances between objects continue to grow, making collisions or gravitational interactions exceedingly rare. The fabric of the cosmos becomes thin, sparse, and hauntingly still. These wandering remnants are the final echoes of galactic grandeur, silently floating through an ever-deepening void, reminders of a universe that once teemed with light and life. Level 18. Cold black dwarfs. Collide. As the universe drifts further into its twilight, black dwarfs, frozen, dense remnants of once shining stars, populate the darkness. These stellar corpses, having cooled over trillions of years, no longer emit light or heat. They are nearly undetectable, slowly gliding through the cold, expanding cosmos. However, in this vast sea of silence, rare events still occur. On extremely rare occasions, two black dwarfs may drift close enough to be drawn together by gravity. After eons of gradual spiraling, they can eventually collide. Though these collisions are incredibly infrequent, separated by intervals far longer than the current age of the universe, they can release a brief, faint burst of energy, possibly reigniting nuclear fusion for a short moment. These quiet, ghostly explosions pierce the darkness ever so slightly, like dying embers in an infinite night. They are among the final flickers of activity in a universe approaching complete stillness, tiny echoes of a once brilliant stellar era. Level 19. Black Hole. Dominance. In the distant future, long after stars have died and galaxies have faded, the universe enters an era where black holes reign supreme. These immense objects, formed from the gravitational collapse of massive stars or the merging of dense remnants, now dominate the cosmic landscape. They are the final titans of structure, silent, invisible giants scattered across an ever-expanding void. Black holes are incredibly long-lived, outlasting every other form of matter. For trillions upon trillions of years, they persist, slowly swallowing any stray remnants that drift too close. Yet even black holes are not eternal. According to Stephen Hawking's theory of Hawking radiation, they gradually lose mass over inconceivably long timescales by emitting tiny amounts of thermal energy. The larger the black hole, the slower the process. But eventually, even the most massive will begin to shrink and fade. In this age of black hole dominance, the universe is ruled by darkness, inertia, and patience, inching ever closer to a final, silent transformation. Level 20. Black holes evaporate. Even the most massive black holes, those that once dominated the universe, are not immune to the slow, inevitable decay of time. According to Stephen Hawking's groundbreaking theory of Hawking radiation, black holes emit tiny amounts of energy due to quantum fluctuations near their event horizons. This process causes them to gradually lose mass. While this evaporation is imperceptibly slow for large black holes, it never truly stops. Over a mind-boggling timescale, estimated to be on the order of 10 to the power of 100 years or more, even the biggest black holes in the universe will shrink, weaken, and eventually vanish in a final burst of radiation. This marks one of the last energetic events in the universe. No stars, no galaxies, not even black holes will remain. Just a cold, dark expanse filled with low-energy particles and fading radiation. The universe, once vibrant and full of structure, slips into silence. With the evaporation of black holes, the last whispers of gravitational giants fade forever into the void. Level 21. The Era of Nothing. With the final evaporation of black holes through Hawking radiation, the universe transitions into its ultimate phase, the Dark Era, also known as the Era of Nothing. In this bleak epoch, no stars shine, no planets orbit, and no black holes loom in the darkness. All complex structures have broken down. What remains is a thin, cold soup of elementary particles, photons, neutrinos, electrons, and perhaps some stable remnants like positrons or dark matter, drifting endlessly through an ever-expanding void. Temperatures hover just above absolute zero, and the vast distances between particles make meaningful interactions incredibly rare. Time continues, but change becomes nearly non-existent. The universe is now a place without light, without structure, and without purpose, just a vast, silent expanse of entropy. It is the long, quiet aftermath of everything that ever was. The cosmos persists, but in a state that is eerily close to true nothingness. A dark eternity without end. Level 22. Heat death. Heat death is one of the most widely accepted theories describing the ultimate fate of the universe. In this scenario, the cosmos has expanded and aged to the point where it reaches thermodynamic equilibrium, the state in which all energy is evenly distributed, and no usable energy remains to fuel processes or sustain complexity. Without temperature differences, no work can be done. No stars burn, no particles collide with purpose, and no life, no matter how advanced, can survive. The universe becomes a vast, dark, and silent expanse, cold and unchanging. Entropy, the measure of disorder, has reached its maximum, and the arrow of time loses meaning. All events cease, not with a bang, but with an eternal whisper of nothingness. This is not an explosion or collapse, but rather a slow and absolute fading away. The universe still exists, but it is utterly still, a cosmic graveyard where even time itself seems to stretch infinitely, with no milestones, no movement, and no memory of the vibrant past that once was. Level 23. Maximum entropy. Entropy, a fundamental concept in thermodynamics, measures the amount of disorder or randomness in a system. From the Big Bang to the fading echoes of black holes, the universe has been marching steadily toward one inevitable destination: maximum entropy. In this final state, all energy is uniformly dispersed, and every form of structure has broken down. There are no stars, no galaxies, no planets. just a cold, dark expanse where particles are spread thinly and evenly across an incomprehensibly vast void. Without differences in temperature, pressure, or density, no processes can occur, no reactions, no motion, no life. The universe becomes static, silent, and inert. Light no longer shines, and information can no longer be organized or preserved. This is the end state of all things, a place where time stretches on, but nothing changes. The cosmos, once full of vibrant energy and complex structures, is now a uniform haze of maximum disorder, a perfectly balanced emptiness, the quiet conclusion of existence itself. Level 24. The Photon Era. In the unimaginably distant future, after all matter has decayed and even the last black holes have evaporated, the universe enters a final, ghostly phase known as the Photon Era. In this age, all that remains are photons, elementary particles of light, alongside a smattering of other near-massless particles like neutrinos. These photons are not the vibrant beams of light we associate with stars or galaxies. Instead, they are cold, low-energy remnants stretched thin by the continuous expansion of space. Their wavelengths grow longer and longer, drifting toward infinity, until they carry barely any energy at all. The universe, now a vast, silent sea of stretched-out radiation, has lost all structure, all warmth, and all form, no atoms, no gravity wells, just endless, fading photons gliding through an ever-expanding void. This is the final whisper of the cosmos, light without illumination, motion without meaning, a universe reduced to its simplest, most entropic state, cold, dim, and eternal. Level 25. Space expands forever. As the universe enters its final stages, dark energy, the mysterious force driving the accelerated expansion of space, continues to exert its quiet but relentless influence. If this expansion persists indefinitely, space itself will keep stretching forever, growing vaster and emptier with time. Galaxies, once clustered together, will drift farther and farther apart until they vanish beyond each other's observable horizons. Eventually, even the nearest cosmic neighbors will become unreachable, not because of distance alone, but because space between them expands faster than light can bridge the gap. Communication, travel, and interaction across galaxies become permanently impossible. Over time, all points in the universe become increasingly isolated, surrounded by nothing but darkness. The very fabric of space continues to grow, stretching infinitely, carrying with it the last flickers of radiation and energy into the unreachable beyond. The cosmos becomes a lonely, ever-widening sea, expanding without end into silence. Level 26. The Big Freeze. Among the various theories about the universe's ultimate fate, one of the most widely accepted is the Big Freeze. In this scenario, the cosmos doesn't end with a fiery explosion or a dramatic collapse. It simply fades away. As space continues to expand, galaxies drift apart until they are no longer visible to one another. Star formation halts, black holes evaporate, and matter itself decays, leaving behind a cold, dim sea of subatomic particles and stretched-out radiation. Temperatures across the universe approach absolute zero, and energy becomes so evenly distributed that no processes, no light, motion, or life can persist. Over unimaginable timescales, the cosmos grows darker, colder, and quieter, slipping into a state of eternal stillness. This is the Big Freeze, a universe that doesn't end in chaos, but in silence. A slow, inevitable decline into emptiness, where everything that once was, stars, galaxies, life, is reduced to memory, written in fading photons, echoing through an infinite night. Level 27. The Big Crunch, alternate theory. While current observations strongly support an ever-accelerating expansion driven by dark energy, some earlier cosmological models proposed a very different fate for the universe: the Big Crunch. In this alternate scenario, the expansion of space would one day slow, stop, and reverse. Gravity, pulling on all matter in the universe, would eventually overcome expansion, causing galaxies to draw closer, stars to collide, and everything to collapse inward. Over immense timescales, the entire cosmos would shrink, heating up as it compresses, eventually condensing into a dense, hot singularity, not unlike the state from which the universe began. Some have even speculated this could lead to a new Big Bang, in a cyclical model of cosmic rebirth. However, with the discovery of dark energy and its accelerating effect on cosmic expansion, the likelihood of a big crunch has diminished significantly. Still, it remains a powerful poetic vision, an ending where everything returns to the beginning. Level 28. The Big Bounce, speculation. Building on the idea of the Big Crunch, some speculative theories in cosmology propose an even more intriguing possibility: the Big Bounce. In this model, if the universe were to collapse under its own gravity, shrinking back into a hot, dense singularity, it might not be the end. Instead, that collapse could trigger another Big Bang, giving birth to a new universe. This process could repeat endlessly, with the cosmos undergoing cycles of expansion and contraction, death and rebirth, in a kind of eternal cosmic heartbeat. The Big Bounce suggests that the universe has no true beginning or end, just infinite iterations of time and existence. While elegant and deeply fascinating, this idea remains highly speculative. We lack the observational evidence and a complete theory of quantum gravity needed to confirm such a process. Still, it offers a hopeful alternative to finality, a universe that never truly ends, but always finds a way to begin again. Level 29. Vacuum Decay. Among the more mind-bending and speculative ideas in modern physics is the concept of vacuum decay, a theoretical doomsday scenario rooted in quantum field theory. According to this idea, our universe may not be in the most stable possible state, but rather in a false vacuum, a local energy minimum that only appears stable. Somewhere, deep in the fabric of reality, a bubble of true vacuum, a lower energy, more stable state, could spontaneously form through quantum fluctuations. If this were to happen, the bubble would expand outward at nearly the speed of light, destroying everything in its path. As it spreads, the laws of physics as we know them, forces, particles, even the structure of atoms, could be rewritten or cease to function entirely. There would be no warning, no escape, and no survival. While this scenario is purely theoretical and highly unlikely based on our current understanding, it's a chilling reminder of how little we truly know about the foundations of our universe and how fragile it might be. Level 30. Quantum tunneling ends. It all at the deepest level of reality, the universe is governed by quantum mechanics, a realm where randomness and uncertainty reign. One speculative yet fascinating possibility for the ultimate end involves a quantum event known as quantum tunneling. In quantum physics, particles can sometimes tunnel through barriers that would be impossible to cross under classical laws. If, somewhere in the vastness of space, a particle were to suddenly tunnel into a new, lower energy state, it could trigger a catastrophic chain reaction. This change might spread at light speed, transforming the vacuum of space itself and fundamentally altering the laws of physics. The result? Everything. Atoms, stars, galaxies could be instantly wiped out or restructured in a way incompatible with our existence. This would be sudden, unstoppable, and unnoticeable until it's already happened. While it's purely hypothetical and incredibly unlikely, it's a reminder that even at the end of time, the unpredictable nature of quantum mechanics might still have the final say. Level 31. Boltzmann brains. In the unimaginably distant future, when the universe has reached near maximum entropy and is little more than a cold, dark void, a strange and unsettling possibility arises from statistical mechanics. The Boltzmann brain. Named after physicist Ludwig Boltzmann, this idea suggests that, given infinite time and random quantum fluctuations, it's more probable for a single self-aware mind to spontaneously form out of chaos than for an entire orderly universe like ours to exist. These disembodied brains could briefly emerge in the void, complete with false memories, thoughts, and sensations, hallucinations of a universe they never truly lived in. They would perceive themselves as real, living beings in a familiar world, even though they are simply freak quantum anomalies destined to dissolve as quickly as they appear. It's a deeply philosophical and unsettling idea. If the universe lasts forever, are such random, lonely minds the ultimate inheritors of existence? And could we, ourselves, be one? Level 32. Final light fades. In the final chapters of the universe's story, even the last traces of light begin to disappear. As space continues its relentless expansion, the few remaining photons, the final embers of cosmic radiation, are stretched across the growing void. Their wavelengths lengthen so dramatically that they lose nearly all their energy, becoming so redshifted they are effectively undetectable. What was once brilliant starlight, warm infrared glow, and faint microwave background becomes a dim murmur of existence, too cold and weak to interact with anything. These photons no longer warm, illuminate, or even register in any conceivable detector. They simply fade into the deep silence of space. At this point, light, one of the universe's most defining and vibrant phenomena, has essentially vanished. No more illumination, no more visibility, just the memory of brightness stretched thin over eternity. The cosmos, once ablaze with stars, becomes truly lightless as the final glow is absorbed by the infinite dark. Level 33. Information loss. Debate, one of the deepest and most puzzling questions in theoretical physics, is whether information about particles, matter, and quantum states is truly lost when it falls into a black hole. According to classical interpretations of general relativity, anything that crosses the event horizon is gone forever. However, this clashes with the principles of quantum mechanics, which insist that information must be conserved. This conflict gave rise to the black hole information paradox, famously highlighted by Stephen Hawking. Does information simply vanish when a black hole evaporates? Or is it somehow encoded, perhaps in the radiation the black hole emits, or on the event horizon itself, like a cosmic hologram? Some theories suggest that the very fabric of space might store this information, subtly woven into the structure of reality. Others propose that what seems like destruction is actually transformation. The debate continues, unresolved, at the intersection of gravity, quantum physics, and the nature of reality, hinting that even in death, the universe might still remember. Level 34. The Planck era ends. In the final age of the universe, after all structure has decayed, light has faded, and entropy has reached its peak, only time itself remains. Even in total stillness, time ticks on, slowly, silently, without purpose. Seconds become centuries, centuries become eons, and eons become stretches of time so vast they defy imagination. But in a universe where nothing changes, where no particles collide and no events unfold, what does time even mean? Without motion, without contrast, the passage of time becomes an empty concept, technically present, yet stripped of all function. The universe enters a state beyond decay, beyond silence, beyond darkness. This is the far end of the cosmic journey, where even fundamental concepts begin to unravel. The so-called Planck era, a scale where quantum gravity once ruled in the earliest moments of the cosmos, has come full circle. Now, there is no activity, no memory, and no future. Time remains, but only as a ghost of meaning in a universe that has truly ended. Level 35. The Silent Universe. At the end of all things, the universe becomes a vast, lifeless expanse, silent, empty, and still. All stars have long since burned out. Planets have crumbled or drifted into black holes that have themselves evaporated, and every trace of complex matter has decayed into subatomic particles scattered thinly across a boundless void. There is no light, no warmth, no structure, no observers to witness its silence, no questions left to ask. This is the silent universe, a cosmos that has aged beyond memory, beyond change, beyond purpose. Expansion continues, endlessly stretching space until even the most fundamental particles are separated by unimaginable distances. Time flows, but nothing marks its passage. It is a universe that has played out every note, told every story, and now exists only as a fading echo of what once was. From the brilliance of the Big Bang to this final stillness, the journey has ended, not with a bang nor a whimper, but with an infinite, unbroken silence. Level 36. The Eternal Now. In a universe devoid of motion, interaction, or change, the concept of time begins to dissolve. Without events to distinguish moments, time loses all reference points. No beginnings, no endings, no progression. The past, present, and future blur into a single, unchanging moment. This is the eternal now, a timeless state where the cosmos simply exists, frozen in its final form. The ticking of time requires contrast, a sunrise, a heartbeat, a flicker of light. But in the end state of the universe, there is only stillness. No clocks, no cycles, no observers to count the seconds. It's not that time stops, it's that it becomes irrelevant. The infinite has arrived not in grandeur, but in perfect sameness. Every point in space looks like every other. Every moment feels exactly the same. The dynamic universe that once birthed stars and life has transitioned into a static, eternal present. In this final stage, time no longer flows. It simply is, an endless and unchanging now that stretches beyond thought, beyond meaning. Level 37. A new physics? As we peer into the far future of the cosmos, our conclusions, entropy, heat death, the end of time, are all drawn from the limits of our current understanding. But what if we're only seeing part of the picture? Perhaps our theories, brilliant as they are merely the scaffolding for something deeper yet to be discovered. Future minds, artificial or biological, may uncover new laws of physics, concepts that reshape everything we thought we knew about space, time, energy, and existence itself. Could the death of the universe be just a phase? Could the fabric of reality fold in ways we can't yet imagine, giving rise to renewal, rebirth, or even escape into parallel realms? Maybe endings are illusions, artifacts of limited perspective. In the silence of the far future, hidden truths may still lie waiting, encoded in the quantum foam or buried in the dark geometry of spacetime. The story may not be over. It might just be paused, waiting for a new kind of reader to turn the next page. Level 38. The universe as a simulation. One of the most provocative philosophical and scientific ideas is that our universe might not be fundamental at all. It could be a simulation. In this view, everything we experience, matter, time, space, even consciousness, could be the result of computations running on some vast, unknown substrate, overseen by entities beyond our comprehension. If this is true, then the universe doesn't end with entropy or cosmic collapse. It ends when the simulation does. Perhaps it's shut down, like a computer program reaching its conclusion. Maybe it's rebooted into a different form, or abandoned, frozen in digital stillness. In such a model, reality is a construct, and its fate depends not on physics, but on the choices or indifference of its creators. This raises profound questions. Are there safeguards? Is someone watching? Could there be multiple simulations, infinite iterations of existence? And if our universe is simulated, what does that make us? Are we code with consciousness? Or just echoes in a grand experiment? Level 39. The Omega Point. Amid the many theories of the universe's end, one stands apart for its ambition and hope: the Omega Point. Proposed by thinkers like Pierre Teilhard de Chardin and later explored by physicist Frank Tipler, the idea imagines a future where intelligent life doesn't fade away, but instead evolves, expands, and ultimately merges with the fabric of the cosmos itself. As the universe nears its end, whether through collapse, simulation, or eternal expansion, this superintelligence would find ways to manipulate entropy, harness energy with unimaginable efficiency, and compress infinite thought into finite time. In this vision, the universe becomes self-aware through its own creations. Every experience, memory, and life could be preserved, simulated, or even resurrected in a final burst of informational perfection. The Omega Point is less a death and more a transcendence, a cosmic awakening at the edge of time. Whether reality supports such a destiny is unknown, but it represents perhaps the most optimistic ending imaginable. Not silence, but synthesis. Level 40. End through observation. In the strange world of quantum mechanics, observation isn't just passive, it plays a fundamental role in shaping reality. Particles exist in a haze of possibilities until they're observed, collapsing into a definite state. This has led some to a provocative, if speculative, question: what happens when there are no more observers? If consciousness, or some form of measurement, is required to lock in the universe's reality, then perhaps the final end comes not with entropy or darkness, but with the extinction of the last mind capable of observing it. Once the last conscious being is gone, does the wave function of the universe collapse into nothingness? Or does it drift into superposition, undefined and unresolved? This idea dances on the edge of physics and philosophy, blending quantum theory with metaphysical wonder. It suggests the cosmos and consciousness are intertwined and perhaps inseparable. In this view, the universe ends not with fire or frost, but with the closing of the last eye, the last thought, the last awareness.